So you've been doing analytical geometry for a bit, it seems. This is your third lesson. So today we're going to tackle points and lines on circles. So these questions are basically about stuff like, does the point lie on the circle, outside the circle, or within the circle? So if you want to take a screenshot of this, I would recommend it because you're going to need it as we go down into the questions. So maybe you want to quickly jot it down or just take a screenshot so that you can keep referring back to it. So it is possible to verify whether a given point lies inside the circle, inside, on the circle, or outside of the circle. So if we're on the Cartesian plane, and imagine there's a circle with a center. You guys have learned now about the circles with the center. That's not at the origin, but it can be at the origin, but the ones we deal with in the trick mostly not at the origin. So it's off center. And, you know, and we're looking at a particular point and we want to know just by looking at that point, where does it lie, inside, on, or outside the circle? So to do this, you must compare the distance between the given point and the center. So the distance between that point and the center of the circle with the radius of the circle. And I think these little diagrams Teacher Lee's got here will help you understand that a little bit better. So here's our circle, and here's the center. And so the center has coordinates, whatever that might be. It could be anything really. And we have a radius. And here's our point also with any coordinates. And if it lies within the circle, then this is basically the distance we are going to be looking at. This distance here is TC. And if that distance is smaller than the radius, then that point lies within the circle. So here's our radius, and it kind of makes sense, right? Because if that little piece of line that connects T to the center is shorter than the radius, then it must lie within the circle somewhere. It could be there, it could be anywhere really within the circle. So that's the first option, or the first scenario that we might get. So the second option, and I'm going to kind of call it option 1, 2, our second scenario, is if this point that we are interested in, point T, lies on the circumference of the circle. And here's my center again. So we can see that if we connect that point T and point C, and we get that distance again, TC, then that distance is going to be the same as the radius because it's the distance from the center to the circumference of the circle, which makes it the same distance as the radius. All right, so that's that one. And then our sort of third option, or the third scenario that we can get, is that TC is bigger than R. So it's longer. The distance from our center is further. The distance from our center to our point T, this point on the outside, is further than what the radius is. And if it's further, it makes kind of sense, right? That it will need to lie outside of the circle because there's my radius, this little orange bit. And if this particular point is outside of the circle, then the distance between the center and that point will be greater than the radius. So here, TC is greater than the radius. Here it equals the radius. And here we have TC smaller than the radius. Okay. So take a screenshot of that. Make sure you've got that handy because we're now going to do some questions and we're going to need that. Right, so here's our first question. Does the point A lie inside, on, or outside the circle x minus 7 squared plus y plus 10 squared equal to 49? So I think the best thing to do before we start is to write down what the coordinates of the center is and what the radius is. Can you tell me in the chat what the coordinates of the center of the circle is? Just put it in the chat. What will the coordinates of the center of the circle be?
Here we go, my people.
Let's get some more answers. How many are we strong? We are 83 strong. So let's get some answers, guys. Be nice to hear from everybody. Even if your answer's there, just put it down, then you know you've entered the game.
Yeah, because you'll have to mark after that. So well done, guys.
Right, so to get our center, just a reminder again, to those of you maybe I've forgotten, we look at what is inside these brackets for x and for y, and we solve them as if they are equal to 0. So if x minus 7 is equal to 0, we're going to get the x coordinate of our center to be 7. And if y plus 10 is equal to 0, then we're going to get negative 10 as the y coordinate. So 7 and negative 10. And sorry, was someone saying? Were you saying something, Miss Yolanda?
No. I'm just
Okay.
telling everybody, please stay muted, guys, because we can hear the background. So please stay muted. Thank you.
Okay, and what's the radius? Pop that in the chat for me as well. Yeah, that's the easy part. We just take this number and square root it. So the square root of 49 is going to be 7. Okay, so now we're going to put the pieces of our puzzle together. We're going to work out the distance from A to C. Distance of AC. And for that, we can just use our distance formula, right? Because that'll work for a distance. So distance formula, here's A, there's C. And why are we working this out? Because we want to know if the point A lies inside, on, or outside the circle. So we're going to go 2 minus 7 squared, that's 6 minus 10 squared. And then we hook that up in the calculator. Hi, Lisa. And if you've got an answer for me, pop it in the chat. Let's go get grade 12s. Let's all get on it. We've got the square root of 289. Sorry, 281, which is going to be 16,76. If we round it to 2 decimal places, best to put it in decimal form so that we can actually compare it. And we can see that the distance from AC is 16,76 and the radius is 7. So that falls within this this last one, where TC is greater than R. So our distance, AC, is also greater than R. So therefore we can say that A lies outside the circle. Okay. Any questions so far? If you're happy with that and that makes sense, put a thumbs up in the chat. Let's see how everyone's coping with that so far. We've got a question. Go for it. You can unmute yourself and ask your question. Is it Janeth? Janeth.
Yes. I wanted to ask, where does this 281 come from?
The 281 comes from plugging it into your distance formula, the coordinates of A and the center of the circle. So what we did over here. So put that into your calculator and you'll see that that is what you get.
Oh, okay. Thank you.
Yes, C is 7 and -10. I substituted it in here. So just remember when you sub in a negative. So it's 6 minus -10.
Okay.
Yeah. And
Thank
so
you.
just put it into your calculator. You'll see that that's what you get.
Okay.
Right. So we're going to go to exercise 3. And it's your turn to do question 1.1. I'm going to give you about 3 minutes to do this one, and we'll check back in, see what you get. In the meantime, feel free to post a question in the chat or post a question to myself or to Ms. Yolanda.
Yep, guys, let's try it out. Let's try out. And Sandy, please make sure that you're muted, okay? I keep on muting you because, of course, we don't want to hear any other background if you are not talking. If you're not talking to teacher Ms. B or to myself.
Ms. Yolanda, I taught grade 7 for the first part of this year, for term 1.
How was it?
And there you just disable this everyone. So, you know, we can always do that, but we don't want to.
No, because my metrics are very clever. They know that they need to stay muted.
So,
but I can imagine the grade 7s. Woo!
Yeah, this
I do that with the grade 8. So yeah, I really do. Sometimes I'm like, no, I can't give you the freedom to.
Yeah, and then we also just disable the chat as well.
Really? Even the
So
chat?
they must just sit in this. They're very naughty. They're very busy.
Yeah, I'm sure. Yeah. But
So
I'm glad
now,
because all the grade 8s are behaving well, and I'm sure it's because they got all the training from the grade 7 lessons.
from Miss Cat. Miss Cat,
Yeah.
hey?
Anna, do you have a question? I think Anna was talking. Anati, do you want to say something?
Yes, if I may ask, when
Yes.
did analytical geometry start?
Analytical, I don't know, Yolanda, you'll know better. 2 lessons ago, so last week, Tuesday.
Yeah.
Or if I may ask, how much time may I spend per day for these lessons?
Do you go to school?
Yes, my current problem is that I attended schools from 6:30 a.m. to 2 p.m. and then from 2 p.m. to 5 p.m. that is when I go home.
So are you home already from 2 p.m. to 5 p.m.?
No,
Yeah.
from 2 p.m. to 5 p.m. I'm still in school for extra classes.
Yo, do you go to school for that long? From 6:30 till 5 o'clock?
Yes.
I'd say you're doing a lot already. Everyone's different, but it does sound like you're doing a lot already, but you also need to, you know, like going for classes and stuff, that's great. And that really helps. But you also have to spend time alone with the content and with the work to make it your own. So I would say probably for a matric, about 45 minutes to an hour. Does that help? Or does that make it worse? I'm sorry.
No, it's just that Anati, I couldn't get, for me, I couldn't understand your question. So you mean in terms of attending Watobe's classes that you don't have time to attend at 5 until 6? Should you rather maybe attend a class between 6 until 7? Is that what you're trying to figure out, or you were just asking in general? I see Anati has logged out. I see. Everyone on the chat, you can put done if you are done like this. Miss B can see that we are all done. So rather put done, and like this, we can do the corrections all together. There we go. Thank you so much, my people. Y'all are amazing. Okay, looks like we are ready to get the answer.
Okay, so I've written down so long the center and the radius, and I've started finding the distance between the center and this point that we are looking at. So I'm substituting into the distance formula now, and then we are gonna, what did I put first? Oh, by the way, remember that if you put the center coordinate first for X, then the center coordinate for Y must go first as well. So I just double checked mine there as well. And then we get a distance. I see some of you got the distance already, so pop that in the chat if you know what it is. All the people who have said done, feel free to share your answer in the chat. So we've got 16 plus 4. Yeah, I get root 20. Root 20 or 4,47.
Well done, guys. Well done.
So is our point
right.
Is our point in the circle, outside the circle, on the circle? Which one is it? Put that in the chat as well. It's inside because it is smaller than R, therefore inside. Okay,
Ooh,
excellent.
Well done. Well done, guys. We are nailing this.
So now let's have a look at question 1.2. Because 1.2, they've made it slightly harder for us. It's not always going to be smooth sailing. So we can't tell what the center is by the equation the way it is at the moment. So what are we going to do to determine the center of the circle for this equation? Who knows? Nice and klar, that's it. We are going to complete the square.
Ooh, well done, guys.
Excellent. So here's our square, and the sorry, here's our first sort of grouping of terms, which is x squared minus 8x, and I always leave a little space because I'm gonna use that space to complete the square, and then plus y squared minus 6y, and we don't want that -2 there. It's not part of the story for completing the square. So we're going to move it across and we're going to put it on the other side. So where I'm going to complete the square, I'm just going to put this highlight here. So when we complete the square, we look at the -8 that's in front of the x, and we add half of what is in front of it. So it's half of -8, which is -4 squared. And then we do it let me just do this. So we can't just add stuff to equations. We need to keep things equal. So if we add -4 squared on one side, we must add -4 squared on the other side as well. And now we're going to complete the squares for the y's. So we've got plus y squared minus 6y and we need to take half of -6 and add it, so and square it, and half of that is -3 squared. Oops. Just scroll back up.
And remember to take screenshots.
I don't know why my pen is suddenly not working so like, but anyway. So everything I've added here is part of completing the square. Let's double check the question. Oh, you're right. Thanks so much, Angelique. Guys, just double check. I made a little slip here with the plus sign. It's plus 6y. And not minus 6y. Okay, so now we're going to make our bracket for x squared minus 8x plus -4 squared. And that's going to be x minus 4 squared. And then y plus 3 bracket squared. And on this side, we've got 2 plus 16 plus another 9. You can just put that into your calculator and see what that gives you. Plus 9. 27. Great, Siamtana agrees. How are we all doing with completing the square? It's one of the key skills you need for analytical geometry and working with circles. So if you also do it when you find the turning point of a parabola. It's one way to find the turning point of a parabola. So the distance, I calculated it and it gave me 8, but I checked twice if my answer is correct or not. November, which one is D? We are busy with 1.2 now, so I'm not sure if you're speaking about the previous question or this question. So if you could just clarify for me, I'll be able to help. We are still just completing the square so that we can see what the center of the circle is. Because the question asks that we figure out if this point, 4 and 1, lie on the circle, outside the circle, or inside the circle. And we can't really start that calculation if we don't know what the center is, because we need to work out the distance from the center to that point so that we can compare it to the length of the radius. That's the whole logic behind it. That's why we are doing it. So, and that's a part, that's an important thing with maths, is if you can just understand why we are doing something. Like, why are we now finding the center? We're finding the center so that we can find the distance between the center and this point, so that we can compare it to the length of the radius. And that way know if it's inside, outside, or on the circle. Alrighty, so we still have to carry on working here. We've got some work to do. Here's our point. Here is the center of our circle. So the center is going to be 4 and -3. And our point is 4 and 1. So go ahead now and calculate the distance. The distance between C and the point. You divided 16 by 2. Where is the 16? No, when you complete the square, the only thing you divide by 2 is the coefficient of x and the coefficient of y. So that's why we say -8, and then that's what you divide by 2 to get the -4 that I've highlighted here in blue and square, added on both sides. And you do the same for the y's. 6 divided by 2 is 3 squared. Add on both sides, and now we've completed the square, and we can tell what the center of the circle is. No. Okay, so we can do the distance. And that just is going to give me 4. Yeah, I agree, 4. And from here, we can see that R is the square root of 27. Don't forget to square root the radius, eh? So whatever number is here at the end, that is the square root. 9 plus 6 is 25 plus 2. Yep, square root of 27. There was a question, I'll take it now, and that's 5,19. If we round to 2 decimal places, 5,2. Therefore, the distance is smaller than the radius, and it is therefore out through inside the circle. That's it. Good job, everyone. Good job. Okay, so here's one slightly more challenging. Let's see. So for question 2, it says calculate the values of P if point A, -3P, lies on the circle. Come, let's try. We can find a way through by just using what we know. So if the point lies on the circle, what did we say about that distance? And maybe what you can also do is, if you're not sure what to do, draw a picture. Draw a picture. Here's my circle. Here's the center, so you can already fill in the center. So let's start putting some clues together to the puzzle. The center of the circle is 2 and 1. The radius is root 50. So here's my center, and somewhere on the circumference, well, we have a clue, it's at -3, so it must be on this side somewhere, because this is 2, that must be -3, lies this point A, of which we know the x coordinate, but we don't know the y coordinate. And some of you are already putting some, are they answers, or I'm not sure, is it the square root of 50 that we're getting here? Let's see, is the square root of 50, the square root of 50 is 7,07. Okay. So if point A lies on the circle, how's that going to help us find what P is? How will we do this? Does anyone have any ideas that they want to share? How will we do this? You can fill in more detail into your sketch. Who's got an idea how to do it? Put your hand up if you want to try. Is P equal to 1? I don't know yet. I haven't worked it out. We can't assume it's 1, eh? If you've worked it out to be 1, maybe it is, but we can't say that it's that A and C are directly across from each other. It's not to say. Ma'am, I'm not sure. Let me read what people are saying. Ma'am, I'm not sure, but do you have to solve for P? Yes, you have to solve for P. Sub in R to the distance formula as the outcome of the formula, distance formula. Yes, that's it. We are going to use the distance formula, and we're going to end up with an equation where we have to solve for P. So if we look at our distance formula, and if we know that this point lies on the circle, then the distance from A to C must be the same distance as the radius. So distance of AC, let's just start by putting in the things that we have. So we have an x coordinate. And a y coordinate. Okay. And remember, we only want one thing that's unknown. When we're solving an equation, we just want one thing that's unknown unless we have a simultaneous equation. So the other thing that we do know is what the distance of AC must be. It must be the square root of 50. I'm going to simplify a little bit, make this easier. Okay, and now we're going to get rid of these square root signs, and we can do that by just squaring both sides. Corner out the square root signs, and that gives me 50. -5 squared, I can simplify as well, it's 25. P minus 1 squared. Okay, Lisa, we will go back a little bit at the end. Okay, so now we can solve, get our variable alone on one side, that's 25, P minus 1 squared. Now we can multiply this out, or we can just be efficient and take another square root. But when I take a square root, remember that it can be positive or negative, because -5 times +5, so -5 times -5 is 25, or 5 times 5 is 25. So my one option is that p minus 1 is equal to -5, or p minus 1 is equal to 5. So that's where the plus minus comes in. Solve for p on both sides or in both equations, and we get -4 is equal to p, or equal to 6. Where did the 50 go? We squared it. Oh, here in this step, we subtracted 25 on both sides. Yeah, go for it, please. Ask a question. You can raise your hand.
Ma'am, why don't we distribute the square with p minus 1?
You can. It's just a bit more work. So if you wanted to go 25 is equal to p minus 1 times p minus 1, then we have p squared minus 2p plus 1, and we have a quadratic that we have to solve. And we factorize that quadratic, p minus 6, p plus 4. And that gives me p is 6, or p is -4. So if you wanted to do it this way, this was another way. If you chose to multiply these brackets out, then you can solve for p in that way.
Thank you, ma'am.
Okay, no problem. Any more questions? Let's see. Yeah, good. It's always good if we can do things in different ways and get to the same answer.
Yep, so many ways to kill the cat. Well done, guys. Well done. I hope you have screenshots.
Yeah, and remember, our recordings are available after class. It's fine.
Yep.
It's perfectly fine if you used with the method I wrote down in green. It's going to work just as well. Over the years, I've just gotten lazy, so I just try and take shortcuts. But you can't, because you're symmetric and you have to still do your best.
Yeah, to find things in the correct way. No, and also because they get marks for steps. So depending on how many marks it is, you need to show all your steps.
Yeah, always show steps, but be efficient at the same time.
Yeah.
Because in the exam, time is of the essence. Okay. Grade 12s, are we good? Do we have time for one more question from Miss Lee's bag of tricks here? Okay, let's see. Got a few minutes. Yeah, we should be able to finish this one. So we have in question 5, a circle with center M, and it touches the y-axis at E and passes through F. So write down the coordinates of E and F. Any ideas? Yeah, of course you can screenshot. Any ideas about, yes, Sinclair, let's hear your question or your answer, whatever it is.
Ma'am, I don't know if I'm right, I might be wrong for E, but I think for E it's going to be -5 and 0.
So E is on the y-axis. So our x-coordinate is going to be 0 because it has to be on the y-axis. So wherever there's where any x value on the y-axis has a value of 0, and then we go across to our y value. So because of this here, our y value here is going to be the same. You see it is on the y-axis, so we're going to move that way, and it's going to be 2. I'm wondering how we are getting -2. Just think again, guys, because we are, look where E is, it's on the positive side of the y-axis. So it can't really be -2. So just rethink your answer there. No problem. X is equal to 0 because E is on the y-axis. Everywhere on the y-axis, X is equal to 0. Okay, let's try for F. So F is directly underneath M, so we can do that. We can say that the distance that F and M are directly underneath each other. Be careful to say that it is 0 because F is over here. So check where F is. So F can't be 0. It needs to have another value. Who said over here -5 and -2? So use image or clues, because if you look at this vertical distance, that is 2. So what will this total distance be? So up to there is 2, and we need another. So what will that be as your y coordinate? -2. I agree. Those of you who are saying -5 and -2, I do agree. Well done. Okay, so sometimes these questions look really difficult, but if you just sit with it a little bit and you reason it out in terms of being on the Cartesian plane and the fact that this is a 90-degree angle, means that this distance has to be the same as this distance. I just want to check. There's something about this that's making me a little bit nervous to say that it's -2. Just double check. Mashilenda, do you agree that it's -2, or should it be -3? I've confused myself.
I think it should be -2. Let me just go through the calculation. Sorry. I'm not
Because
following.
the radius, sorry, if we work with the radius, that is 5.
Yeah.
And then this is 2, and this must be another 3. So this whole distance must be 5 as well, because it's the radius. So I'm going to change my answer, guys. I am going to say that it's -3. And I think someone else also said that. I saw that. Danielle, yes. There were a few people, yeah. Okay, let's look at that one again. So, and I'm going to rub all of this out. So because this x coordinate here is 5, it means that the radius is also 5. So this distance here is the radius, and that is going to be 5. And that we get from the fact that that x coordinate is 5. So then this must also be 5. And we know that this is 2 from this x coordinate. So that vertical distance is 2. So this must be 3. And because we're moving in the negative direction, it should be -3.
Oh,
Yeah, I think I feel better about that.
yeah, actually, that makes sense.
Yeah, so already I've just corrected the fact that it should be -3. Yeah.
-3, guys. Let's just get the corrections. I also thought it was -2 at first. But if you look at it correctly, it's -3 because we have to have a radius of 5.
Yeah.
So 2 plus 3 gives us 5.
Okay, so next up is for you to find the equation of the circle, question B. So remember, for the equation, we need x minus a squared plus y minus b squared equals the radius squared. I think that might be the last one we have time for. So we're going to sub in our center. So our center is x plus 5 squared and y minus 2 squared, and our radius we can also say is 5 squared. There we go. And then you can square that out, make that 25, and that's your equation. We have the center and the radius. All done. That's all you need. All right, we're going to have to stop there.